Can you solve this without the normal identity we know for the sum of two cubes? That is a squared plus b squared equals to a plus b all squared minus 2ab. I think for this question, I don't think it's going to be possible. So I manipulated an expression for the sum of two squares to be able to tackle this problem. But if you have any other way of solving this, you could share in the comment section. Now, um, to solve this problem, I need to rewrite the sum of two squares as this, as I manipulated a squared plus b squared is equal to 1 over 2 a plus b all squared plus a minus b all squared. Yes, I think with this identity we could solve this problem. So, and then let's rewrite the first equation. Let's rewrite this equation by saying it becomes a plus b. So a squared plus b squared should be written as what we just have here now, multiplying 1 over 2 a plus b all squared plus a minus b all squared and equal to 85. So how can we get rid of this 2 here? This 1 over 2 here is by multiplying through by 2. Yes, because the reciprocal of 1 over 2 is 2. So multiplying everything by 2 here, we have it to be a plus b, and then we have a plus b all squared plus a minus b all squared. Since I'm multiplying both sides by 2, multiplying 85 by 2, we have 170. Yes, so this becomes my new equation 1. Now let's rewrite this second equation here. Of course, we notice or we should observe the difference of two squares here. So on the right hand I will have a minus b, and for the difference of two squares here it becomes a minus b and then a plus b, which is equal to 45. So notice that this term here are the same and they are multiplying, so this becomes a perfect square, and I will have a minus b all squared times a plus b then equal to 45. So this becomes my new equation 2. So let's set them up properly. So then I would say, since we have I observe some terms here, a plus b and a minus b, I'm going to use some substitution. I will say let a plus b be equal to x, and let a minus b equal y. So I plug it in equation 1 and 2 respectively, and I'll have a plus b to be x, and I'll have it here again as x squared plus a minus b is y is squared, then equal to 170. So in equation 2, a plus b is still x, and then a minus b is y, which is squared, and then equal to 45. So I think we can expand here. This implies that x times x squared is x cubed, x times y squared, that is plus xy squared, equal to 170. So, but what do you observe here? I'm observing x y square here, and still xy square to mean 45. So I can now plug in this value in here. That is, I'll have therefore that x to the power of 3 plus xy squared means 45. So I'll put down 45 here, then equal to 170. Taking like terms, I will have x cubed is equal to 170 minus 45, and this is going to give us 125. So taking the cube roots on both sides, x is equals to the cube root of 125. So this is equals to 5. So we have that our x is equals to 5. So let's plug in this value of x in this equation here. This equation here, let's plug in the value of x in this equation here. So we're gonna have that because xy squared is equal to 45, so therefore my x becomes 5, then y squared equal 45. So I'm going to divide both sides by 5, dividing both sides by 5, then y squared is equal to 9. So taking the square root of both sides, y is equals to the square root of 9, which is plus or minus, y is equals to plus or minus 3, which implies that y is equals to minus 3 or 3. So let's recall that a plus b is equals to x from our previous work, that a plus b is equals to x and a minus b is equals to y. So I will have that. I'm gonna have that. So a plus b is equal to 5, and also as we know that a minus b is equals to y, so we can write as well that a minus b is equal to, let's use any of the values here. Any of the values can solve minus 3 or 3. So I'm going to use the positive value. The negative value still works as well. So you could try it on your own self. You will get the same answer. So we solve this by elimination method. So let's eliminate b from here by adding. So a plus a is 2a, b plus minus b is gone, 5 plus 3 is 8. So dividing both sides by 2, it implies that a is equals to 4. Yeah, so since I've gotten my a, I can put this value in this equation here. Let's call this equation 3 and this equation 4. So I can put the value of a in equation 3. So from 3 says a plus b is equal to 5. So my A is 4 plus my B is unknown equal to 5. So B is equals to 5 minus 4. So B is equal to 1. So you see, I got my values. My A and B values is now equals to, the value of A here is 4 and the value of B here is 1. So we could try the same thing if there was a minus 3 here. Just the same thing works. That is, I will have A plus B equals 5 and A minus B equals to minus 3. So doing the same thing, let's start by addition. So A plus A gives us 2A. B plus minus B is gone. 5 plus minus 3 is just 2. Dividing both sides by 2. So it implies that A is equal to 1. So I'll put this value again in this equation here. So I'll write from the equation A plus B equals to 5. You can call it equation 3. So I will have that my A is 1 plus B, I don't know, equals to 5. So B is equals to 5 minus 1. B gives us 4. So our value here for A was still let's say A comma B, which is equals to, our A here was 1 and B here was 4. So this change happened because we had two values of y, which was minus 3 or 3. So the value of A and B here is 4 1 or 1 4. So I hope you learned from this manipulation of identity here that I used. So keep watching, subscribe and like, share as well. Thank you.